Bismillah ar-Rahman ar-Rahim. This is teacher Iman al-Khalidi explaining today from chapter 7 integrations. Section 7-3 integration by substitution. We are going to tell you some ways and methods of integration. The first way is integration by substitutions. And second, integration by parts. Third, integration of partial fractions. Today we are going to focus on the first way, which is integration by substitution. And we have some rules in that. Rules of integration by substitution. The first rule is the integration of a function to the power of n of x multiplied by its derivative f dash of Lx dx. In that case, you're going to add this power by 1 and divide by the power itself plus c. That happens if n is not equal to -1. Remember, be sure that you have a function to the power of n and its derivative beside it. Otherwise, you can't add it by 1 and divide by. And the other case, if n is equal to -1, what you supposed to do? You are going to flip this function from up to down to get f dash of x over f of x. And think about the original function will give you the derivative of the numerator over the denominator. That will take you back to len the denominator of f of x. Because if you derive this, you will go back to f dash of x over f of x. And don't forget to write the plus c. The third, if you have an integration of an exponential function e to the power of u multiplied by du. And what is u? U is a nonlinear function, which is a function has a variable, its power is not equal to 1. In that case, you are going to write your answer, which is e to the power of u plus c. Be sure that it is multiplied by the derivative of the power. The fourth, the integration of sine u times du. It is negative cosine u. Remember, u is non-linear function, and it is multiplied by the derivative of the angle. So here be sure that the derivative of the angle is multiplied by. That will make it the answer negative cosine the angle plus c. And that can be similar for all trigonometric functions like cosine and tan and all others. Integration of len u times the derivative of that function, which is du. That will give you that rule, which is u times len u plus c. The next is an integration of len x to the power of n multiplied by the derivative of len x, which is dx over x, or sometimes they can write it 1 over x dx. In that case, you're going to add the power by 1 for the function divided by the power n plus 1, and that happens when n is not equal to -1. This takes you back to the idea in 1. It is similar, which is the integration of a function. Here our function is mentioned len x to the power of n multiplied by its derivative, like here exactly. It is multiplied by its derivative. In that case, you are adding the power by 1 and divide it by and plus c. That happens when n is not equal to -1, and we have similar in number 6. Now we're going to have two new ideas different than these, and we can call them special cases. In 7, to integrate the square root of difference between two squares. Difference between two squares under the root. You are going to have a special type of substitution, which is let sine u equals to bx over a. Sine u equals bx over a. Here bx is coming from the second term. Just take the square root of it. Over, also a is coming from the first term. Just take the square root of it. Then you are going to derive these and substitute it in the integration. The last case, which is if we want to integrate a fraction, dx over x multiplied by x to the power of n plus or minus a constant called a. Or if they let this x multiplied with that inside to give you x to the power of n plus 1 plus and minus ax. Let in that case x equals to 1 over u and then derive it. You will get dx equals negative 1 over u squared du. Then replace it and integrate. Remember, you are going to use the last, which is x equals 1 over u instead of that, which is instead of 1 over x, like that. When we are going to use that way, we are going to use it actually if we are going to use it actually if we have the power n for the whole for x only, not for the whole bracket. If it is for the whole bracket, you are going to use rule number one. But if it is partially for 1x inside the bracket, so you are going to use rule number 8. So this is the difference. Now, we are now ready to take some exercise and examples. Let's now start. Example number 1, which is saying integrate 5x plus 2 to the power of 5 over 2 dx. We can say that if we have a function to the power of 5 over 2 and 5 over 2 is hard to expand it. In that case, you're going to use rule number 1. Rule number 1 is saying that the function to the power of n, you should add it by 1 and divide it by n plus 1. Now, I can see that the derivative of that inside beside it. Because of that, you are going to substitute it in that way. Watch it. You are going to let by using any letter. You can use U or you can use the letter T, Y, Z, any letter you would like to. I am using U. So here, let U equals to the thing which is inside the bracket. Don't take the power. Don't take the power. Then derive it. You will get the derivative of U, which is du, and the derivative of 5x, which is 5, and the derivative of the constant is 0. Then you have to write in terms of x, because you can imagine when you're gonna write du over dx, it is the derivative of the letter u in terms of x, but we make a cross multiplication for it to make it in that side. This is easier for you when you are integrating each side separately. Now we need to make the x as a subject like that. Dx equals to du over 5. Then replace it in the integration, which is that. Like that exactly. Integration of u to the power of 5 over 2 times du over 5. From where we got that, we are replacing 5x plus 2 all by u. And write it here with the new power, which is 5 over 2. Multiply by n before we have dx, and we have a deal that dx we make it as a subject after we derive it. So we're going to replace it by du over 5 from this step, which is du over 5. I can see that this 5 is constant and it is in the denominator. So I can take it as a common factor like 1 over 5 outside, then integrate what is left, which is u to the power of 5 over 2 du. According to rule number one, if you have a function to a power and its derivative beside it, so add the power by 1 and divide it by the result. So by adding 5 over 2 by 1, say that 5 plus 2 is 7 over the denominator 2. Whatever you will get up, divide it by. You can flip this 2 from down to up and make it 2 over 5. This 5 you can multiply it by 7 to get there 35. And you can later replace or return back u to what it was. It was from the beginning 5x plus 2. So you now substitute it again to write it in that way. 2 over 35, which is the constant, multiplied by 5x plus 2 to the power of 7 over 2 plus c. I am done with the first example. I want to say something. You can use that long way or you can use a short way. The short way is from the beginning. You can see that the derivative of that inside is not written, which is 5 only. So from the beginning, you can divide by 5 to get the answer and to write it 1 over 5 and directly add the power by 1 to get 7 over 2 and divide by 7 over 2 and you will get finally the result, which is that in one step. This is easier, of course. You can use it when you are solving objective equations. Let's now go to B. If we have an integration of a 3x squared with a square root of 5x to the power of 3 plus 4 dx, you can see that this is our function which has a power, which is half. So we are going to take what is inside it without taking what is outside it and without taking the root itself. So you are going to start from here. Let u equals 5x cubed plus 4. Take only what is inside the root, wherever the root is. Now you are going to derive each side separately. Derive the left side. The derivative of u is du. The derivative of 5x cubed is 15x squared by taking the power down and reduce it by 1 dx because you are deriving in terms of Lx. Next, you need to make the dx as a subject by dividing both sides by 15x squared. So you will get du over 15x squared. Then substitute it in the function itself or in the integration itself. Integration. You have 3x squared square root of 5x cubed plus 4 dx. Keep 3x squared as it is. You just consider what is inside the root by u. And you make dx as a subject in terms of u from the previous step. In that case, you can write instead of dx, du over 15x squared. Then you can cancel or simplify your work. X squared with x squared is 3 with 15 to get 5 down. And because it is a constant and it is still in the denominator, you can take it outside as 1 over 5, which is constant. Then integrate what is left. U to the power of half du. The integration of that similar to what we studied before. Add the power by 1 and divide it by the result. You will get 1 plus 2 is 3 over 2. So you're going to write 3 over 2 divided by the result that you will get. The denominator of the denominator goes up to be 2 over 5. This 5 multiplied by 3 will give you 15. This u to the power of 3 over 2 plus c. Now we are going to return back this u as it was. It was exactly from the first step, 5x cubed plus 4 to the power of 3 over 2. From here, from the first step, this example is done. We can now have another. Another example is saying that integration of 0 from 0 till pi over 2. You can see that we can also deal with the integration with definite integrals. For sine cube y, cosine y dy. And here you can see that we have sine to a power of a 3 with the letter y. And it is multiplied by the derivative of sine, which is cosine. So we are still dealing with rule number one. We're still dealing with rule number one. And you can see that till now, rule number one is the most famous one gonna be used. So it is multiplied by cosine y, which is the derivative for what is inside the power. So now we are going to add the power by 1 to make it sine 4 over 4. And that's it. Then you are going to use fundamental theorem to evaluate. Or you can use that long way. You can consider what is inside the power by u, or t, or z, or whatever the letter you would like to. Then derive it. Du equals the derivative of sine is cosine y in terms of y. Make dy as a subject, which is du over cosine y, and replace it and substitute it. Here you have a small problem, which is your interval. It is in terms of y. That means this 0, it's a value of y, not u. This 0, it is a value of y, not u. You are going to change it to in terms of u. How? By this step. In this step, I will change the limits of the integration, the definite integration, from 0 to pi over 2 to something relate to u by using this statement. Let us see. When y is equal to 0, which is from here, when y is equal to 0, we can say that u equals to sine 0, which is 0. So u gonna be changed to 0. It is the same here. Next, we can say that when y equals to pi over 2, when y equals to pi over 2, we need to know how much is u. According to this statement, u equals to sine pi over 2, which is 1. Now you can say that your limits gonna be changed from 0 to pi over 2 in terms of y everywhere to 0 to 1 in terms of u. Now let's replace everything. We are going to replace instead of sine y by u to the power of 3. Keep cosine y because you didn't consider it from the beginning as it is. And replace instead of dy that you get it from the second step from here. You're going to replace it by du over cosine y, which is here. Now you can cancel cosine y with cosine y to get finally the integration from 0 to 1 for u cube du. Just add the power by 1 to get u 4, divide it by 4, and try to use fundamental theorem from 0 to 1 by replacing once by 1 here and once by 0. Let's do it. 1 to the power of 4 is 1. 1 to the power of 4 is 1 divided by 4 minus 0 to the power of whatever it is 0 divided by 4 it is 0. So the last answer is 1 over 4. We said that way is a long way to solve. You can use an easy way than this, which is from the beginning, you can say that because I have sine to the power of 3 and it is multiplied by its derivative, you can add the power from the beginning to make it 4 and divide it by 4 to get that result quickly. You can come from the question to that answer in one step. But you have to be sure that the derivative of the angle or the derivative of, sorry, the function is beside it. We're still using rule number 1. But you have to change the letters or from 0 to 1 and then replace. Now we are going to have new ideas and new examples. In this example, you have x to the power of 4 sine x to the power of 5 dx. You're going to start always from the angle. When it is non-linear, you have to start from the angle because it is non-linear. Non-linear, that means the power is not equal to 1. Now you are going to call this x to the power of 5 something like u. U equals to x to the power of 5. You know now from where you're going to start. Always from the angle if it is non-linear. Now derive each. Du equals to 5 goes down, x to the power of 4 by subtracting the power by 1 dx. Make dx as a subject. You will get dx equals du over 5x to the power of 4. Replace it in your integration, which is exactly like that. You're going to keep x to the power of 4 because you didn't consider it with u and write sine u. And now it changed the x to du over 5x 4. You can cancel x4, x4 with x4 together and take this 5 from the denominator outside as it is in the denominator as a constant and integrate sine u du. You can say that the answer is negative cosine u. And now replace or return back this u as it was x to the power of 5. This is the answer plus c because it is indefinite integral. Let's have more ideas and more examples. The next example is talking about integration of exponential function, which has x cubed plus 6x multiplied by x squared plus 2 dx. You can see that the power is non-linear. Why it is non-linear? Because the highest power here is not equal to 1 is not equal, the highest power of x is not equal to 1. In that case, you are going to use substitution method by considering the power by u or any letter you would like to. U equals to x to the power of 3 plus 6. Remember, you are going only to consider u by the power, only the power, whatever the power is. Now you are going to derive it. If you're going to derive it, derive each like that. You can say that you will have du equals to the power goes down, reduce it, and here 6x, its derivative is 6 in terms of x. Now take this 3 as a common factor. Open a bracket and write x squared plus 2. By taking the 3 common factor, you are dividing each by 3. You will get x squared plus 2 dx. Here, the next, we are going to say that make dx as a subject. So here, dx equals to du over 3 times x squared plus 2. Then substitute it instead of each, like that. The integration of e to the power of x cubed plus 6x multiplied by x squared plus 2 in terms of x. You are going to replace the power and call it u. Substitute. It's u. And keep that beside because you didn't take it with your considering. So leave it as it is. But multiply it by the du over 3 times x squared plus 2, which is replaced instead of dx from this step, which is replaced instead of dx from this step. Then you can cancel x squared plus 2 with x squared plus 2 to get the following. 1 over 3 is a constant, goes outside. Integration of EU du. 1 over 3 goes outside, and e to the power of u plus c, we can integrate it by the same because it is an exponential function. So its integration is the same. Plus c because it is indefinite integral. Now you can return back this u to what it was. It was exactly x cubed plus 6x. So return it back as it was, a plus c. Now we're going to have a new ideas with a new examples. If we have an integration of x squared over x cubed plus 2, you can see here we are integrating a fraction. In a fraction, you are going to start from the denominator. In the fraction, you have to start from the denominator and name it by a new letter, like U, T, Z, whatever you would like to. So I consider the denominator by U. U equals x cubed plus 2. Only take the denominator. Now derive it separately. Derive the left side to get du equals 3x squared and dx. Make dx as a subject. Du over a 3x squared. Make dx as a subject and replace it instead of in the integral. So the integration of x squared over x cubed plus 2 dx gonna be changed. X squared up, keep it as it is because we didn't consider it first. But the denominator, we make it as u. Multiply by. You change dx in terms of dy in the previous step to be du over 3x squared. You can cancel now x squared down with x squared up to get 1 over 3 outside as a constant with the integration of du over u. This takes you back to the rule of the len. Len the denominator because the derivative of the numerator for the denominator. You have a fraction and you can see that the numerator is derivative of the denominator. And this is getting you back to the original function, len the denominator, which is like that. 1 over 3 len of u inside absolute value because len doesn't accept negatives, plus c because it is indefinite integral. 1 over 3 goes out, len return back u as it was. It was x cubed plus 2 plus c. The next example with a new idea. We have again fraction. And in this partial fraction, we are going to start like usual from the denominator. Call it u. Let's do it. The first consider is let u equals 3 plus cosine 2x. Derive each, you will get du equals 2. The constant 3 is 0. The derivative of cosine is minus sine 2x multiplied by the derivative of the angle, which is 2. dx, make dx as a subject, which is du over negative sine 2x. Whatever you can write the negative, it works. You can write it in front, you can write it up, you can write it down. Now you're gonna substitute in the integration. Exactly like that. Sine 2x, we didn't consider it from the beginning, so keep it as it is. It's all over we consider the denominator by u. So let's write u down. Multiply by. We just replace dx in terms of du from the previous step, which is negative du over 2 sine 2x. We can cancel this sine 2x from down with sine 2x from up to be cancelled, and then we will take 1 over 2 as a common factor with the negative. You will get finally integration of du over u. Like we did before, this is related to len. Len, the denominator. If you're going to have a fraction, the numerator is derivative of the denominator. So it take you to len. Len of the denominator. Don't forget to write the absolute value because len doesn't accept negatives. A plus c. You can arrange your work by returning back this u to what it was in terms of x, which is len 3 plus cosine to x plus c because it is indefinite integral. Or you can write it in that way. Now we can have a new example with the new ideas. Calculate the following. Integration of sine to the power of 3x dx. Now, this sign has an odd power, and we give you q to the power of 3, and it works for all functions or trigonometric functions for any odd power, for any odd powers. So let us see. You're gonna expand it by sine square always. You have to write it sine square always and multiply by sine x. Now, you have a rule for sine square, which says from the relations between sine and cosine, you can use this relation, which is 1 minus cosine square x. Here you can see that we choose this relation and we didn't use the double angle identity here because you want to keep the angle the same. Here the angle is x and we keep it x. So don't use here the double angle identity. You should use the relation between sine and cosine. Next step, you're gonna expand this bracket by multiplying sine with the first and this sine with the second. You will get integration of sine x minus cosine square x times sine x in terms of x. Now integrate each separately. The integration of sine x is minus cosine x. The integration of cosine, like we did it before in detail. Now we're going to do it in a short way. If you have cosine to the power of 2 or whatever, something more than 1, you are going to add this power by 1 and divide it by, but you have to be sure that its derivative beside it according to rule number 1. If its derivative not beside it, you can't do that. So here, and remember the derivative of, or sorry, if you go to get cosine in the integration, you always have to make negative beside it. So negative times the negative is positive. This is the idea for the first one. Let's have more ideas. We have an integration of dx over x times x cubed plus 1. You can see that we have the power 3. It is above x partially, not completely for the denominator. So if it is completely here to the power 3, you can take it from down to up and make it negative 3. Then you can deal with it with rule number 1. But if the power is not for the whole denominator, it is on a special time or a special letter like x separately. So you are going to use rule number 8, which has a special type of considering, which is that one. Let's talk about it. Integration of the x over x to the power of 4 plus x by multiplying x inside. It is not necessary actually to multiply it, but if you multiply it, you will get the same answer. Here we are going to have a special type of considering. You're going to say that let x equals to 1 over u. This x, we're going to consider it by 1 over u and derive it. The derivative of the left side is dx. The derivative of 1 over u, it is negative 1 over u squared in terms of u. Make the u, or no, just keep it because you have dx as a subject. Always we are trying to make dx as a subject. In this case, we have it already as a subject. Now you need to substitute. To substitute, you're going to say that dx is going to be replaced by negative 1 over u squared du. Over this x, we're going to replace it by 1 over u to the power of 4. We'll make it 1 over u to the power of 4. Plus x is 1 over u. We replace instead of each x by 1 over u. Equal the denominator down. To equal the denominator, you need to multiply this by u to the power of a 3 up and down to get 1 plus u to the power of 3 over u to the power of 4. You know that the denominator of the denominator, we can take it from down to up to be here, closer together and farther or the farthest together. So you will get u to the power of 4 over u to the power of 2 all over 1 plus u to the power of 3. You can cancel u to the power of 4 now with u square to get negative u square all over 1 plus u cubed. You can remember here the rule of len. If you have the numerator up, is the derivative of the denominator. You're going to use len, but be sure it is completely the derivative of it. Here I can see that there is missing 3 because if you're going to derive the denominator, you will get 0 plus 3u squared. 3u squared. This is the derivative of the denominator. And you don't have a 3 up. So the idea is easily you can multiply by 3 and divide. If you multiply by 3 and divide, it makes sense. So now you have completely the numerator is the derivative of the denominator. And this negative, you can take it outside. We don't want it. So here is 3u squared is completely the derivative of the denominator. And that will take you back to the rule of len. Here, len the denominator, which is 1 plus u to the power of 3, all plus c, because you are dealing with indefinite integral. We have finally negative 1 over 3 len, 1 plus. We can return back this u as it was. U was 1 over x from here. We can make a switch. U is there and x is here. So 1 over x. If you cube it, you will get instead of u to the power of 3, 1 over x to the power of 3. All plus c. Always return back the u in terms of x. I am done with my lesson. If you have any comments, any questions, please write it for me. And don't forget to share, subscribe, and like. Thank you very much.